Imagine teaching a friend how to recognize dog breeds. At first, you might show them lots of pictures and name each breed. Over time, they start spotting the differences themselves, without you having to explain each one. Machine learning, ML, is the computer version of this learning process. Instead of programming every detail, we give the computer data and let it find the patterns and solutions on its own. In essence, ML is about training computers to learn from experience. With enough data, they start to make predictions, classify objects, spot trends, or even play games, all by figuring things out from the examples we provide. It's like giving the computer a puzzle to solve and a few clues to get started. And with practice, it gets better and better at it. Just as there are different ways to learn new skills, there are different types of machine learning to handle different tasks. Here's a quick look. Let's first dive into supervised machine learning. Imagine for a second that you're teaching a child to recognize apples and oranges. You have a basket of fruits, and you're guiding them through each one, saying, "This is an apple," or "This is an orange." After enough examples, the child starts getting the hang of it, able to tell an apple from an orange on their own. Supervised machine learning is a lot like this. Instead of fruits, though, we give a machine examples with labels, a kind of cheat sheet that tells the machine what each thing is. We're training it to recognize patterns or categories based on what we show it. Here's how it works in 3 simple steps. First, we gather a bunch of data, which are simply examples of the problem we're trying to solve. So, let's say our goal is to train a machine to recognize cats and dogs in photos. We'd need a big pile of images labeled with either cat or dog to get started. Next, we use this labeled data to train a model. A model is just a fancy name for a program that finds patterns in data. The model studies each labeled image, looking closely at the features that might distinguish a cat from a dog, like the shape of the ears, the length of the tail, or even the texture of the fur. Through lots of practice, it learns to spot these differences. Finally, once our model has learned enough from the labeled data, we can test it with new, unlabeled examples, images it hasn't seen before. This is like handing the child a new fruit and seeing if they can figure out whether it's an apple or an orange. If the model has learned well, it'll recognize the correct label, even without us telling it. Now, in the world of supervised machine learning, there are 2 main types of tasks: classification and regression. Classification is when we're sorting things into categories, like cats and dogs, or emails into spam and not spam. Regression, on the other hand, is when we're predicting a number, like the future temperature based on historical weather data. To sum it all up, supervised machine learning is about showing a machine examples with labels, training it to recognize patterns, and then letting it predict the right labels on its own. Just like teaching that child about fruits, it's all about giving enough guidance and practice so they can eventually make decisions independently. And that's the beauty of it. With enough training, these models can start making accurate predictions in the real world, helping us in everything from organizing photos to predicting prices and beyond. Let's next dive into the world of unsupervised machine learning, which is a bit like letting a computer explore a new landscape all on its own. Imagine you're in a massive library filled with books scattered everywhere in no particular order. Now, your job is to organize them, but here's the catch. You don't have a map or categories to work with, and no one's given you instructions. You can't peek inside to see what's important about each book, but you can look at patterns on the covers, groupings on the shelves, and start figuring things out yourself. This is essentially what unsupervised learning is all about. Unlike supervised learning, where the machine gets taught using data labeled by humans, here the machine has to figure things out on its own. It explores and organizes the data without any labeled examples guiding it. In other words, it tries to find patterns, structure, and relationships within the data without any instructions. So what does this look like in action? Let's picture it like an artist given a blank canvas with a huge variety of colors and tools, but no instructions about what to paint. Maybe they start by grouping similar shades together, blues with blues, yellows with yellows, or by identifying contrasts, like dark colors versus light colors. Through this exploration, patterns start to emerge. Unsupervised learning models do something similar. They try to uncover natural groupings or hidden structures in data. One of the most popular types of unsupervised learning is called clustering. Imagine you have a big basket of fruits, oranges, apples, grapes, bananas, all mixed together. A clustering algorithm would help the machine look at features like color, size, and shape to start grouping similar fruits together, like all the oranges in one group and all the grapes in another. It's not that the machine knows what an orange or a grape is, it just spots similar characteristics and decides to form groups based on those. Another common unsupervised method is dimensionality reduction. Picture a huge spreadsheet full of different types of data, say customer data at a store, which might include hundreds of details like age, income, purchase history, and so on. Dimensionality reduction helps simplify this information, shrinking it down into a smaller, more digestible version without losing the key patterns. It's like taking all that information and finding a way to summarize it in a few more meaningful traits. Unsupervised learning is widely used for tasks like customer segmentation, where businesses want to find natural groups of customers without knowing in advance what those groups should look like. It's also used for detecting anomalies, like identifying unusual patterns in credit card transactions that might suggest fraud. At its heart, unsupervised learning is like a curious explorer. It starts with no map and no instructions, just patterns and clues scattered throughout the data. Through observation and analysis, it begins to see structure where there once seemed to be none. And in doing so, it reveals insights that can be incredibly valuable, helping us make sense of complex data and uncover hidden connections that we might not have spotted on our own. Now let's dive into semi-supervised learning. This approach is like having a mix of two worlds, the well-defined structure of supervised learning and the flexibility of unsupervised learning. Imagine a situation where you have a massive stack of unlabeled data, let's say thousands of photos of animals, but only a small batch of those photos is labeled. You know that 50 of these are tagged as cat, dog, or rabbit, but the other 950? They're a mystery. In semi-supervised learning, we use that small portion of labeled data to help the model make sense of the large unlabeled pile. It's a bit like giving a student a short list of answers before a test. Even though they don't have all the answers, those few clues can help them figure out a lot more on their own. The model learns to recognize patterns in the labeled data and then applies that knowledge to the unlabeled data, effectively teaching itself based on what it already knows. This approach is especially handy when labeling data is tough or expensive. Imagine trying to label medical images. You'd need experts to tell you what each one shows, and that can take a lot of time and money. With semi-supervised learning, you don't need as many labeled examples. Instead, the model uses the few you have as a springboard, drawing conclusions about the rest. It learns in stages, starting with what it's sure about, the labeled data, then gradually building its confidence in handling the unlabeled data. A good way to picture this process is like a person learning a new language. At first, they might only understand a few basic words and phrases, our labeled data. But as they start to pick up patterns and context, similar to the model working through unlabeled data, they can make educated guesses about new words or sentences. They might not get everything right, but they'll become more fluent without having to study every single word one by one. Semi-supervised learning has opened up possibilities in fields where gathering labeled data can be tricky. Think about self-driving cars, for instance. They need to recognize all kinds of things in their environment, but labeling thousands of hours of driving footage would be overwhelming. By learning from both labeled and unlabeled data, these systems get better and better without needing every single image or object to be painstakingly labeled. So, in short, semi-supervised learning is about working smarter, not harder, by training models to use both labeled hints and unlabeled mysteries. This approach is super useful when you have a small amount of labeled data, but a huge pool of unlabeled data, helping models get the most out of limited information. All right, let's dive into the final type of machine learning, reinforcement learning, or RL for short. Reinforcement learning is like training a puppy, except the puppy is a computer program that's learning how to make decisions. This type of learning is all about taking actions to get the best possible reward, even when the puppy isn't quite sure what the best choice is at first. Imagine a robot in a maze, trying to find the quickest way out. At the beginning, it doesn't know where the walls are or which turns will lead to a dead end. So, the robot tries different paths and makes a lot of wrong moves along the way, bumping into walls and getting stuck. But every time it moves closer to the exit, it gets a little reward, like a digital pat on the head saying, "Yes, you're doing great. Keep going that way." If it bumps into a wall, it gets a tiny, negative reward, like a "whoops, not that way." Over time, through trial and error, the robot learns to navigate the maze by aiming for more of those positive rewards and avoiding the negative ones. Eventually, it figures out the quickest path out. Now, in the world of machine learning, this robot is called an agent, and the maze it's navigating is its environment. The agent learns by interacting with the environment, taking actions, seeing the outcomes, and adjusting its behavior based on the rewards or penalties it receives. Just like our robot learns to avoid dead ends in the maze, a self-driving car learns to stay in its lane, stop at red lights, and avoid other cars through reinforcement learning. What makes reinforcement learning different from other types of learning is that there's no fixed answer or label telling the agent what to do next. It's more like a game. The agent's job is to figure out the moves that maximize its rewards over time, even if it has to stumble and explore a bit to get there. Just like in a video game where you try different strategies to reach a high score, the agent keeps adjusting its actions to get better results. Reinforcement learning is often used in situations where there's a clear goal, but not necessarily a clear path to get there. So, you'll see it in things like robotics, where machines need to interact with physical objects. Game-playing AIs, like those that learn to master chess or video games. And even recommendation systems, which learn to suggest the right products by getting feedback on whether people actually like them. In a nutshell, reinforcement learning is about learning from experience, making choices, seeing the results, and using those results to make better choices next time. It's all about trial, error, and improvement. And just like how you might learn to ride a bike by falling a few times, reinforcement learning thrives on a little failure along the way, leading to better and better results as it learns what works.